So in this video, I wanted to help explain a common homework type of question where you're given an initial function, perhaps as an equation like g of x equals negative 2x plus 9, and then you're asked to find its inverse function and then compose, that's called function composition, the original function with its inverse evaluated at a specific number. And then also, what if you're given a function by us telling you ordered pairs on its trajectory? Could you find an inverse at a certain point? So let's take a look at the first case. If we have a function g of x equals negative 2x plus 9, which hopefully you remember is a line. This is of the form mx plus b. So it's definitely a line in which we have a one-to-one function because it passes the horizontal line test. So it should have an inverse. So to begin, the first step when finding an inverse, when you have the equation already of the original function, assuming that it's invertible, one-to-one like it is to switch x and y. So that's step one. If you switch x and y, let's see what we would end up with. The x right now is here, so I'm going to write negative 2y plus 9, so that's a switch. The y is g of x here. Okay, that's your output. So input was x, output was g of x. So now I'm going to make the output the input. So I'm switching the x and the y, switching the domain and the range. The second step in this process would be to solve for y. So to solve for y now, I need to get negative 2y by itself. So I could do that a couple of ways. One easy way is to add 2y to both sides. So I'd have positive 2y on the left. I still have this plus 9 on the right. But couldn't I also move this x to the other side by changing its sign? So I'm moving 2y to the left and x to the right. So it would now become negative x. So what would this mean for me? To solve for y, I would need to divide by 2. So I could divide the entire thing by 2. That's one option. Or I could divide each of them individually by 2. Negative 1 over 2 would be negative 1/2, and 9 over 2 is 4.5. So I would get that y equals negative 1/2 x plus 9/2. So notice it's a different line. So what we're claiming here is, and again, you could have written it either way. Negative x plus 9 could be your entire numerator, and then you could divide the whole thing in half. That's definitely fine, by 2. Or you can write it this way. So what we notice here is that our inverse function, step 3, would be to change the name of y. This is the inverse function. So what was the name of the function? It was originally g. Its inverse is called g inverse. So the inverse function of g is negative 1/2 x plus 9/2. And if you had your graphing calculator, or if you want to do it by hand, or Desmos.com, you could type in both the g function, negative 2x plus 9, you'd have a certain line, and then you could type in negative 1/2 x plus 9/2, you'd have another line. And what you would notice is that their graph should have symmetry about the line y equals x. What you should also notice is that if you were to input the g function into the g inverse function, so wherever you see an x, replace it with negative 2x plus 9, or vice versa, wherever you see an x in the g function, replace it with negative 1/2 x plus 9/2, you should end up with just the original x, which is hopefully what happens in part B. In part B, it asks you to find g of g inverse of 5. So g of g inverse of 5 is really saying, take your g function, which in this case was negative 2x plus 9. So this is really saying g, this means of, g of something. Of what? So we took care of this outer part first. G of something. G of g inverse. Well, g inverse, we found that down here. G inverse of some number. And the number here that they'd like us to evaluate is at 5. Okay, so what do we do first? Well, we could do a couple of things. One thing is if we really trusted and checked that g and g inverse were in fact inverses of each other by plugging them into each other and getting x, the answer here should just be 5 because they should be undoing each other. But if we're not sure, if we want to check in this example, what we'd first start with is the inside piece. And we'd say, well, what would g inverse of 5 be? Well, here's the g inverse function that we found. It would take negative 1/2 times our input, which is 5, so negative 1/2 times 5, and add 9/2 to it. So negative 1/2 times 5 and add 9/2 to it. That would be g inverse of 5. So we're inserting 5 there. And whatever answer we get, we have to plug that in to our g function. Okay, so we're not quite done yet. Let's continue. So g inverse of 5 says take that input 5 and plug it into x for g inverse. Look what we would have here. Negative 1/2 times 5. That's really the same as 5 over 1. So we can multiply those two fractions together, giving us negative 1 times 5 is negative 5, and 2 times 1 is 2. So I would have negative 5 over 2. So negative 5 over 2 plus 9 over 2. Whatever that result is, that's the input for the g function. So let's continue getting that input. 9 over 2 and minus 5 over 2 is 4 over 2. So we know this is 4 over 2. And we're plugging that input into our g function. 4 over 2 is really just the number 2. So this is really saying plug in the input of 2 into the g function. Well, we could do that. Plug in the input of 2 into the g function, and let's see what we get. Right now, we plug in 2 into this g function. We would end up with negative 2 times my input, add 9. My input is 2 in this case, after we did the g inverse of 5. And now I would have negative 2 times 2, which is negative 4, plus 9. Well, what is negative 4 plus 9? If you said 5, you would have been correct. Now, is that what I expected to happen? Yes. If g and g inverse are truly inverses of each other, then when you plug them inside of each other, the function composition should just give you the input of, in this case, 5. All right. So now let's take a look at what to do if you're given an original function that is defined by some ordered pairs. So we just know some points which are on this trajectory. They tell us h is defined by these points, 0, 1, 1, 0, 2, negative 4, 3, 8, and 8, 6. So how do we begin finding h inverse of the number 1? Well, keep in mind, just like we found g inverse earlier when we had the original equation, by switching x and y, keep in mind that h inverse would mean, if I was finding h inverse in this particular case, in general, instead of 0, 1, h inverse would have for its points 1, 0, wouldn't it? It would have, instead of 1, 0, it would have 0, 1. What else would it have? Instead of 2, negative 4, it would have negative 4, 2. Instead of 3, 8, it would have 8, 3. And instead of 8, 6, it would have 6, 8. So that would be the h inverse function if I were to have all the points on its graph. So now when it asks me to find h inverse of 1, it's really saying when the input is 1 in h inverse, what is its output? Just like we did here when we asked you to find g inverse of 5. We said when the input of g inverse is 5, what is its output? And its output was 4 over 2, or 2. Similarly, we can go to our ordered pairs here of h inverse. So we're just switching the input and the output. And now instead of getting the answer h of 0 equals 1, we would say h inverse of 1 equals 0. So the answer here would be when the input is 1 to the h inverse function, what is the output? And the answer should be 0. Okay, so we just simply switched our inputs and outputs. If you want to practice another one, what would it be if I said, what is h inverse of 6? If you said 8, you would be correct. You just go to the input of 6, and you get the output of 8. Okay, so I hope that helps understand how do you find the inverse function, whether you're given the original equation or if you're given some points that are on the map of the function, and then how do you plug in one function inside of another and evaluate at a certain input by carefully working the inside and then the outside. Noticing that if they're truly inverses, you should just get the input there. They should undo each other. Well, I hope that helped, and let me know if you have any more questions. Happy practicing, because remember, math is not a spectator sport. See you next time.